Hi everyone. What I'd like to do is do a really quick focused video on confidence intervals. All of this information comes directly from your notes on this section. However, I did want to do a focused video because sometimes this topic gets a little lost within the notes, and it's something that you will have homework questions on and will need to know. So I wanted to do a real quick focused video. So confidence intervals is going to be done using your calculator. So you're going to need that TI calculator. And you're going to be following these instructions on your calculator, and I will walk you through how to do them. When you get your answer on the calculator, it is going to give it to you in interval notation, which is going to give you your upper and lower values for your confidence interval. The situation we have here is described in the notes. You can read this little paragraph here, but the important piece of information that we really need is your sample size, your mean, and your standard deviation. Okay, once you know those pieces of information, you'll be able to find the confidence interval for whatever percentage confidence the question's asking for. So what we're going to do is jump down to question B. Question A is described in your notes, so we're going to focus on question B and C. Okay, B is asking us for the confidence interval with 95% confidence. So we're going to focus in on this one. And so we're going to find the confidence interval with 95% confidence using the information here highlighted in yellow. So all you'll need to do is follow these steps on your calculator. So I'm going to need you to bring your calculator over, turn it on, and you're going to go to Stat. So that button we've been using a lot for our class. So we're going to go to Stat, and we're going to arrow over to Tests. So I'm going to arrow 2 to the right. Then we're going to choose option 7, Z interval. So arrow down to option 7 and hit enter to select it. Once you've selected it, there's two types of calculations it can do based on data or based on statistics. Since we're doing it based on specific values and statistics given to us, we want to highlight and hit enter on stats so that it is changing to that particular type of questioning. And what it does is it changes the type of prompts that your question will, or your calculator will ask you, and this better helps us with our particular question because this is the information that we need. So we're going to go ahead and arrow down. The first question it's asking us for is the standard deviation. That's the symbol for standard deviation. So our standard deviation is 26 according to our highlighted yellow information. So go ahead and hit 26 and hit enter. It will take you to the next prompt, which is asking us for our mean, or X bar, and that is 172.55. Okay? And then if I go ahead and hit enter down one more, N is your sample size. So the sample in this particular example is 40. So I'm going to click 40. Now your calculator defaults to 95% confidence, which is exactly what we would be looking for here. But if it were ever 90% confidence or 99% confidence, you would take your confidence percentage that you're given and change it to a decimal. So 95 as a decimal is 0.95. And so that's what you'll want to use in your calculator. So that's actually already there for us. I'm just going to arrow down and go ahead and hit calculate. Now, as you can see, this is based on the information we gave it in our stats, and it's giving us this in an interval. And the interval is 164.99 to 180.61. So I'm going to copy that information down. So our interval is 164.49 to 180.61. What this is giving you the lower limit and your upper limit of your confidence interval. And it's saying that with 95% confidence, I know that, or in this range, we know with 95% confidence that this interval from 164.49 to 180.61, we are going to get the true value of the mean. So meaning the mean is going to fall within that range. So I can actually write this in. So we are 95% confident. That's pretty high percent confidence in my opinion, but 95% confident that the interval from 164.49 to 180, so that range in weight, because we're talking in this particular question about the weight of men on various devices, such as elevators, aircraft, and so forth. So in this range of weight, from 164.49 to 180.61, I'm 95% sure that the true value of the mean will fall in that range. Okay? So that's what our confidence interval is asking us to do. So one more time, I'm going to run through it on the calculator. You go to Stat, arrow over to Tests. You're choosing option 7, which is Z interval. Hit Enter. Make sure that Stats is highlighted. It will ask you a variety of prompts. It will ask you for the standard deviation, the mean, and your sample size. It will also ask for what level of confidence you're asking for. Remember, you need to put this in as a decimal. And then you'll hit Enter for Calculate, and it will give you that range. Your lower limit is on the left, and your upper limit is on the right. So hopefully this helps a little bit with confidence intervals. Okay, so the next area of this notes that tends to be a little confusing or somewhat lost in the notes is the idea of finding a sample size. So this formula here is what we'll use to help us find our sample size. Remember, n is the variable that represents your sample size, so that's why we're using this particular equation. So n is going to help us, n equals this equation is going to help us find that sample size. So the first piece of this first part in parentheses, that's your critical value. And you'll get that using the chart at the bottom of your z-score chart. I did do a little cut and paste here, and I have it for the video, so this is what you're looking for on that z-score chart. The second item that we have as a part of our formula here is our standard deviation. And the last part is our margin of error. So all you have to do is find these three values and plug it in this formula for whatever question it is that you're working on, and it will give you your sample size that you should use. Now, one thing I do want to note, that if you are ever given a decimal, which in most cases you will be, you need to make sure to round up. I don't care if you would typically round down with your normal rounding rules. In this case, you'll always want to round up. So always take it to the next number up if it has a decimal. Okay, so the next thing is to actually do an example with this. So in this example, and this comes straight from your notes, but again, I'm just highlighting one to make sure that you are good to go and know that you do in fact need to focus on this, and you will see it in future questions. This is asking about an IQ test, and it says it's designed so that the mean is 100 and the standard deviation is 15 for the population of normal adults. Find the sample size necessary to estimate the mean IQ score of statistics students within 5 points of the true mean with 95% confidence. Okay, so what we're trying to do is we're trying to find this, this sample size. Okay, so we are going to use this formula here. N is equal to, and I'm going to write it in words instead of symbols. So the first one is your critical value. That is going to multiply with your standard deviation. And that's going to be divided by your margin of error. Okay, so now that we have our formula written out in words instead of symbols, because sometimes symbols can get a little confusing, we are going to find those pieces. So the critical value is going to come from that chart that you have again at the bottom of your z-scores. And what you're going to use to know which value to use is that 95% confidence in your question. So that 95% confidence level is going to tell you what critical value to use. So the critical value I'm going to use in this one is 1.96. So I'm going to go ahead and write that in there, 1.96. And that's going to times with my standard deviation. So my standard deviation, they told us, is 15. So I'm going to use 15 for my standard deviation. And then last but not least is my margin of error. And my margin of error is going to come from within, so it's telling us how many points within, so give or take. So it's within 5 points. So our margin of error is going to be 5. So let me go ahead and write that in there. And so now that I have that in there, I'm just going to take my calculator. And remember, this is a quantity squared, so I need to write my square out there. I forgot it in the step above. So whatever you get for that value, you want to make sure to square it. So I'm going to put in 1.96 times 15. That's going to give me 29.4. I'm going to divide that by 5. Let me bring back that calculator. I'm going to do 29.4 divided by 5. It's going to give me 5.88. And remember, that's going to be squared. So I'm going to take 5.88 and square it, take it to the second power, and we get 34.5744. So I'm going to write down the decimal to start. So 34.5744. Now notice, again, we have a decimal, so we need to round up always. Again, even if this were like 0.1, you would still want to round up. So this is telling me that instead of 34, I'm going to write 35. And that's going to be my sample size that I need. Okay, so 35 is the sample size that I would need in order for this situation to occur. So that formula here, again, is just for your critical value, your standard deviation, and your margin of error. Your margin of error should come from your question. It should be like plus or minus, or within so many points. Your standard deviation should be given to you, either with the symbol or with words telling you it's standard deviation. And then your critical value is likely going to be given to you in some sort of percent confidence, and you're going to use your common critical values chart at the bottom of your Z's chart to help you get whatever that critical value is. So once you know those 3 values, you're going to plug them in your formula, evaluate them. You'll likely end up with some sort of decimal, and just remember that you're going to round up. So in this case, my answer would be 35. So hopefully this helps you find your sample size when asked for that, or your confidence interval. All right, good luck.